Hi Year 13s. This is quite an important video, one of the more important ones that I've done along the way, so I'm going to take my time to get through it. But we're talking about the fundamental theorem of algebra, and I've actually alluded to this quite a bit already, and it's to do with the highest power of a polynomial when we're solving it. And what it says is the highest power tells you how many possible complex roots there are. So complex can be real, imaginary, or both. So for example, if we had x to the power 3 equals 7, that has 3 possible roots. Or if we had x to the power of 8 minus 3x plus 2 equals 0, that has 8 possible solutions. So that's what the fundamental theorem of algebra states. So with this first question, before we even answer it, what we should be thinking is that we should have 2 possible answers. Now we're not going to be able to factorize this, and so we're going to complete the square. So we'll have x plus 2 squared, and then we'll have to subtract 4, and we've still got that plus 13 there. And so we can write this as x plus 2 squared equals negative 9, and now we can take the square root of both sides, and so x plus 2 is going to be equal to plus or minus 3i, and if you're not sure why, well, have a closer look at that. And then we can subtract 2 from both sides, so x equals negative 2 plus or minus 3i. So let's check that we've got 2 results here. We do, because the plus and minus gives us 2 distinct results. So we could have x equals either negative 2 plus 3i or negative 2 minus 3i, and those are our 2 answers. Okay, so this is where it gets a little bit different to how it was last year, because last year it was just if there were no real roots, you weren't interested, whereas this year we don't care about real roots anymore, we're interested in all of the possible roots. Okay, this is a similar question but with a slight twist, because it's asking us to factorize. So you remember in year 11 that questions would often ask you to factorize first and then solve. This question's asking you to solve and then factorize. So we'll solve it first, and then hopefully it will become apparent why we can then factorize. So I'm going to do the same thing here, and that's complete the square. So we'll have to subtract 1, and then we've still got the plus 4 there. And so we can write this as x minus 1 squared equals negative 3. And we can square root both sides, so we get x minus 1 equals plus or minus root 3i, and that I is outside of the square root. And then we can add 1 to both sides, so we can say that x equals 1 plus or minus square root 3i. Now we've solved it, which is the first part of the question, but now we need to factorize, and what we really need to remember is that whenever we factorize quadratics in the past, the numbers in the second part of the brackets have always been the roots to the equation, and so those solutions there are going to have to go into there instead of alpha and beta, and that's what represents the root part of our factorization. So we can say that x squared minus 2x plus 4 is equal to x minus 1 plus root 3i times x minus 1 minus root 3i. And it seems a bit odd to have double brackets in there, so we'll simplify that by taking the brackets out, by expanding the brackets, one layer of brackets. So that's x minus 1 minus root 3i, and x minus 1 plus root 3i, and that's our factorization. So now that we have complex numbers, we're able to factorize previously unfactorizable expressions, and that helps us greatly with our progress in algebra. So that should get you set for doing the work on those pages, and yeah, just to reiterate that the fundamental theorem of algebra says that if you've got x to the power of n, then you've got n solutions, and that's the important part of what you've got today.